Hello and welcome to another Orange Coast College mathematics video. In this video, we want to learn some basic set theory, that is, intersections of two sets or unions of two sets. Now, the intersection and the union of two sets are both pretty straightforward concepts. We have them written here, right here. So when we talk about the intersection of two sets A and B, we write it as A, and then this is the intersection symbol, like an upside down U. A intersect B. And what that means is it's everything that is in A and also in B. Okay, so when we write the intersection of A and B, that's the set that is included, everything that's included in both of those two sets. So if you have the Venn diagram, if you're used to seeing Venn diagrams, right, that's everything that they would have in common in here. That would be the intersection. Okay. Now the union of two sets A and B, written as, again, it's easy to remember which one's union and which one's intersection because the union kind of looks like a U. A union B is how we say this. That is just everything that's in A or in B or in both. Okay, so compared to the intersection, if we had the Venn diagram, the union, if one of those sets was A and one of those sets was B, the union would just be everything in either one. Okay, so this would be the union. So that's the union. And then up here, that's the intersection. Let's start with a simple example. Let's find the intersection of this set A, which is the elements -1, 0, 3, 4, 7, and 8, and B, which is 2, 3, 4, 6, and 10. Now the intersection is everything that is, every element that is in both A and in B. So anything that's in both of them. So the easiest way to do this when your elements are just listed out for both of them is to just go element by element and see, is that thing in both of them? So -1 is in A, but not in B. So it means it's not in the intersection. 0 is in A, but it's not in B, so we do not include it. 3 is in A, and it is also in B. So that is included in the intersection of A and B. 4 is in A, and it is also in B. So we do also include 4 in the intersection. Now 7 is in A, but it's not in B. 8 is in A, but it's not in B. And so that's it. We found all of the elements that are both in A and in B. It's just 3 and 4. That's it. Okay, now when we're trying to find intersections or unions of sets, and those sets are written in interval notation or set builder notation, it can be very helpful to graph them to see what's going on. And we want to graph them on the same number line. So here's my number line. The first set, A, is 2 to infinity. So here's 2. And if I want to graph that, I'm going to graph A in blue. I'm going to graph them in different colors. You'll see why in a moment. So 2 to infinity, we do not include the endpoint 2, but it's everything larger than 2. Okay. Now our set B is -infinity to 7. I'll graph that one in red. So here's 7 over here. Okay. So -infinity to 7 would be everything to the left of 7. Not including 7. Now the intersection of the two sets is everything they have in common, everything that's in both. And we can see wherever on the number line we have both red and blue, and I've kind of had them overlap maybe a little too much, that's the intersection. So that would be from 2 to 7. Now the endpoint is not in A, the endpoint 2 is not in A, and 7 is not in B, which means that neither endpoint is in the intersection. So that means the intersection, though, is from 2 to 7. And again, we do not include either endpoint. Okay, in this example, we're again asked to find the intersection of two sets written in interval notation. So again, we will just graph them to see what's going on. For the first one, we have A is from 1 to infinity. So we have 1, not including 1 to infinity. 1 is the left endpoint, infinity is the right endpoint, so we just draw the arrow all the way to the right. For B, it's -infinity to -5. -5 would be somewhere over here. I'll graph that one in red. So -infinity is the left endpoint, -5 is the right endpoint, and we include the endpoint in there. Now we're being asked to find the intersection, but the intersection would be wherever the two sets overlap. But in this case, there is no overlap, right? There's no number on the number line that's in the red and in the blue. So in this case, the intersection is empty. So we would write A intersect B is what we call the empty set. right? We draw a circle with a line through it to represent the set with no elements in it. Here we have an example where we want to find the intersection of sets A and B, and they're both given in set builder notation. Now again, if it's an interval notation or set builder notation, we'll just graph to see if we can figure out what's going on. So here's our number line. For A, we want x such that x is greater than or equal to 4. So let's graph that set. Here's 4. Greater than or equal to means we include 4 and anything larger than 4, which is everything to the right. Okay. Now B is x such that x is strictly greater than 5. So 5 would be to the right of 4. And we're not including this 0.5, but we want everything that's larger than 5. So everything to the right of 5. Okay. And so now the intersection is the overlap, anything that's in both sets. So anything where it's both red and blue. So the intersection of A and B is really anything greater than 5, right? So it's x such that x is strictly greater than 5. Any number that is greater than 5 will be in both sets. And any number that's 5 or smaller will not be in B, so it's not included in the intersection. And so it turns out that this set is exactly equal to B. So the intersection of A and B is actually just B. So we would say in this case that B is a subset of A. It's contained entirely within A. All right, let's do some examples involving unions. Now remember, the union is any element that is in either A or in B, or in both. Now the only thing to note is we don't write elements of a set twice. We don't repeat any of them. So to write the union, A union B, we just really write all of the elements of A and also all of the elements of B, but we just don't want to repeat anything. So we'll write -3, 1, 2, and 4. That's everything that's in A. And then we can write the elements of B, but we don't want to rewrite anything we've already included. So we don't need to write 2. We don't need to write 4. So the only thing left is 6 and 8. And that's the union. It's every element that's in either A or in B or in both. But again, no need to write an element twice. All right, just like with intersections, when we have our sets written in interval notation or set builder notation, we want to graph to see what's going on. So again, our set A is from 1 to infinity, and our set B is from -infinity to 5. So A is from 1 to infinity, so it's everything. The left endpoint's 1, the right endpoint's infinity. So we graph it like that. And then B is -infinity to 5, so the left endpoint is -infinity, and the right endpoint is 5, which again is not included. Now, for the union though, the union is everything that is included that we've graphed. Everything at all. So everything that's red, everything that's blue, that is what the union is, right? Everything that's in A or in B. So A union B in this case, it's everything from -infinity to positive infinity. It turns out it's all real numbers because every number on the number line is in one of those two sets, right? So, 1 might not be included in A, but 1 is included in B. 5's not included in B, but it is included in A. So even both the endpoints are also in there. Okay, so everything is in there. All right, let's do another example. Find the union of these two sets. A, all x such that x is less than -1, and B, all x such that x is greater than 4. So again, as I mentioned before, let's draw a number line and graph these. So for A, we want x is less than -1, and B, x is greater than equal to 4. So let's graph A first. So it's everything less than -1. So it's from -infinity up to -1, not including the endpoint. And then for B, it's everything from 4 greater than 4. So 4 is the left endpoint, positive infinity is the right endpoint. So there's no nice way to write this. The only way to write A union B, if you wanted to write it in interval notation, you could write it as -1, let me go back here, -infinity to 1 union 4 to infinity if we wanted to write it in interval notation. If we want to write it in set builder, it's x such that x is less than -1, and you actually write the word or, x is greater than or equal to 4. There's not really any nice way of simplifying it or writing it. And that's all. Let's do another example. Find the union of the sets A, which is the interval from -6 to 2, including the point -6, and B, -infinity to 7, inclusive on 7. So again, I find it helpful to draw the number line. So A is from -6 to 2, and B will be -infinity to 7. So I'm kind of just drawing the points on there. So A we'll do in blue again. -6 to 2, we include -6. We do not include 2. Okay. And B is -infinity, sorry, to 7. So it looks like this. Okay, we include 7. Now, the union is any number on the number line that is either shaded in red or in blue. So since A is contained entirely within B, the union of A and B, so A union B, is just B. Okay. It's the whole set from -infinity to 7. That's everything that's in A or in B, or in both, is just the set B itself. Okay, last example. Let's find the union of sets A, x such that x is greater than or equal to -4, and B, x such that x is greater than -5. All right, so first we'll do A, x is greater than or equal to -4. So that's everything to the right of -4, including -4. B is x is larger than -5. So not including -5. So it's everything to the right of -5. And again, the union is anything that has been touched by the red or the blue, right? Anything we've graphed there, that's what's in the union. So again, A union B is everything that's in the union of A and B. So anything that's red or blue is graphed by the red, right? So it would just be B, which would just be x such that x is greater than -5. Every element of A is also in B already. So the union of A and B is just B. And that's it for intersections and unions. Again, if you're having any trouble with these, just graph them. If you're having trouble graphing them, go back and watch the video on graphing inequalities on the number line. But once you can master that, then finding the union or intersection of a couple of sets should be no problem at all. Until next time, have fun.